CLR is 8% sulfamic acid. Iron out is mostly oxalic acid. Evapo-Rust, up to 90% water. The same industrial powders behind these brands cost about 10 cents per use. So what exactly are you paying for? Shelves in the cleaning aisle present a specialized solution for every stain. Polished retail bottles feature clean graphics and targeted promises, suggesting custom-engineered science. But safety data sheets reveal a different reality. Many premium liquid removers are simple mixtures of common industrial compounds diluted in water, while some formulas rely on basic oxalic acid or sulfamic acid. Others, designed for rapid action, contain highly corrosive hydrofluoric acid. Hydrofluoric acid is highly corrosive and requires strict protective gear. It sits on home shelves disguised by friendly branding. The convenience of a pre-mixed bottle masks a basic fact. Consumers pay a massive premium for water, plastic packaging, and simple active ingredients that are easily sourced in their raw, concentrated powder form. Preparing a standard rust-removing bath requires simple arithmetic. To mix a standard 5% strength solution, you need 50 grams of chemical powder for every liter of water. Most routine workshop projects, like cleaning rusty wrenches or a socket set, only require half a liter of liquid to completely submerge the metal. That means a single cleaning cycle uses just 25 grams of dry powder. If you use bulk technical grade sulfamic acid, that 25-gram dose costs exactly 10 cents. If you choose bulk oxalic acid, the price drops even lower, to about 1 penny per soak. A modest 4-pound starter bag of these raw crystals provides enough material for over 70 individual batches, easily lasting a typical home workshop through years of routine cleanups. Rust is a chemical compound, formed when iron reacts with oxygen and moisture to produce iron oxide and iron hydroxide. Removing this corrosion requires breaking those molecular bonds. Acids achieve this by converting the solid, flaky oxide layer into soluble iron compounds that easily rinse away. Sulfamic acid works through proton-driven dissolution, acting as a strong, non-oxidizing descaler that strips the corrosion while keeping the cleaning bath completely clear. Oxalic acid relies on a process called chelation. It binds directly to the iron ions, wrapping around them to form stable, water-soluble complexes that turn the water a distinct orange red. Dissolving either of these raw powders in warm water, ideally between 30 and 50 degrees Celsius, accelerates the reaction rate by 2 to 3 times, speeding up the cleaning process without changing the fundamental chemistry. For descaling and lighter surface rust, sulfamic acid is the cleaner option. It reacts quickly without generating heavy vapors or leaving messy residues. And because the bath stays clear, the metal remains visible during treatment. But for rust stains, pitted metal, and tight crevices, oxalic acid is the superior tool. Its chelating action aggressively pulls iron from the steel, turning the solution dark as it complexes the metal. This reaction can leave a light, powdery residue on the finish part that requires manual scrubbing, and heated oxalic baths emit a distinct sour odor. Ultimately, choosing between them depends entirely on the job. Yet both demand the same baseline respect. Both are strong corrosive acids that require chemical-resistant gloves, eye protection, and proper ventilation. These raw acids work wonders on iron, steel, and cast iron, but they are not universal cures. Aluminum, brass, copper, chrome, galvanized coatings, and painted finishes can easily peel or degrade in the bath. Working with concentrated powders demands discipline. Always wear chemical-resistant gloves, goggles, and an apron, and work in a well-ventilated space. Store the dry crystals securely alongside their safety data sheets, and always test a hidden spot before full immersion. Once the rust is gone, Neutralize the spent acid with baking soda to a neutral pH before disposal, keeping concentrated chemical runoff far away from local storm drains. Submerge the rusted wrench into the warm solution. Light surface corrosion clears in 30 minutes, while severe pitting demands an overnight soak. Keeping the bath around 40 degrees Celsius gives the reaction a helpful speed boost. Once the rust dissolves, submerge the tool in a baking soda bath to neutralize the acid before the final water rinse. Dry the metal immediately, and wipe it with a light protective coating of oil. Sourcing these dry powders is easy. Start with small purchases from pool suppliers, industrial chemical outlets, or online lab reseller channels. Complete safety data sheets, cost tables, and hazard checklists are detailed in the description below. Behind every expensive brand is a simple, cheap chemical. Choosing the raw powder isn't just about saving money, it's about outsmarting the marketing. Subscribe for more consumer secrets.